press the bell icon on the YouTube app and never miss another update.
Hi students. So in surface area and volumes, so far we have completed the surface area of different objects we have studied. So now I will move on to volume. So first of all we will deal with volume of a cuboid. So first let us understand volume. So what is volume? Suppose we have a playing figure. Suppose we have a circle on a board, on a paper. We say it is two-dimensional. It is having length and breadth. So it occupies certain area. If it is a three-dimensional object, so like this duster cuboid, it is of cuboid shape, just like a brick. You all have seen the brick. So such objects, they occupy some space. That space, measure of that space is known as the volume. That is the definition for the volume of an object. See, here there are two things. If you, in case of a brick or in case of a say shot put ball, if they are solid in nature, we call it as a volume of the object. Suppose if you take a hollow thing, let us consider a football ball. So here what happens? The inside is void. So similarly, you consider a cubical shape water tank. So inside of which is totally hollow. So here what we say, the inside of that hollow objects, it can be filled with air or water or any liquid. They will take the shape of that container. It may be a water tank, it may be a beaker, or it may be a bowl. The quantity of such material, maybe water, maybe air, maybe any oil, the quantity which is that container or the object accommodates is known as the capacity of the object to hold that much of quantity. So that is why we say the water tank is 1000 liter capacity, 2000 liter capacity, 500 liter capacity, likewise. So it is nothing but volume. If it is hollow and the hollow portion will be filled with some liquid or air, we call it as a capacity of that vessel or container or object. So this is the key difference between volume and the capacity to hold a material. So we'll have some definition for this. Defines as a volume, it is defined as measure of space occupied by objects. So the object means it may be a cuboid, it may be a bowl, it may be a sphere, it may be a right circular cylinder, likewise. So here, if the object is solid, if the object is solid, we call it as volume. We call it as volume. It means what? The measure of the space occupied is called as the volume. So here you can quote the example. So best example is, practical example is brick. So a brick volume, you can always, a brick will be of this shape. It is cuboid in nature. All of you are familiar with this object. So this is brick. This is a brick. Now, so just to know the inner corners, the opposite side corners, we mark it like this, of course. Now, on the other hand, if the interior of object is hollow, hollow means empty, is hollow, it can be filled with air, water or oil or any other liquid. So that will take the shape of the object. That means, what is the meaning of that? If you put water in a bowl, it will take the shape of a bowl. If you put the water in a beaker, it will take the shape of a beaker, shape of the object. In such case, the volume of such objects objects, better you write substance may be water, may be oil, substance which can be filled in the interior of object. interior of object is called capacity of container. A container may be a water tank, may be a bowl, whatever it is. So that is the difference between the volume and capacity. So volume refers to the solid objects, and the capacity of the container refers to the hollow objects where we can fill some sort of liquid or air. So this is all about definition of volume. Now we will move on to the volume of a cuboid. Volume of cuboid. So a cuboid is a three-dimensional object which has length, breadth and height. You are familiar with this and you have calculated the surface area of such objects already. So this is a typical cuboid is the brick. I will write it once again. So this is, say this is a cuboid. So here we call this as length of the cuboid, and from here to here call this as breadth of the cuboid, and from here to here we call it as height of the cuboid. So volume of cuboid is equal to LBH, L into B into H, or we call it as V is equal to LBH. So volume of cuboid is LBH. Now, what happens if it is a cube? Volume of cube. Volume of cube. In case of a cube, you have all dimensions are equal. So this is length will be equal to breadth and it is also equal to height. So therefore these three are equal. We call them as A. If this is A and from here to here, this is also A and height is also A. So L is A, B is A, H is A. So therefore volume will be equal to A cube. So this is the formula for volume of a cube. So cuboid volume V equals LBH. Volume of cube equals A cube, where A is the side length. So these are the two important formulas in case of volume of a cube and cuboid. So now I will erase this. This is all simple. Certain portion of this you have studied in your previous class also. Now we are going to apply these formulas and solve some of the problems. Now, so here it is given this is example, solved example 11. Please refer to your textbook, page 227. A wall of length 10 meter was to build across an open ground. So, the length of wall is 10 meter. The height of wall is 4 meter and thickness of wall is 24 centimeter. If this wall is to be built with the bricks whose dimensions are 24 into 12 into 5 centimeter, how many bricks would be required? So, let us understand the problem. The wall is to be built. So, the wall is like this. A wall is like this. So, I will draw the lateral view of the wall. This is, say, the thickness of the wall. Thickness of the wall is given as 24 centimeter and it is like this. The wall is like this. Try to understand this. So, the wall is look like this. Here, the length of the wall is 10 meter. This is the thickness of the wall, length of the wall. And the height of the wall is 4 meter. From here to here, it is 4 meter. This is L, this is H, and thickness of the wall is 24 centimeter. 24 centimeter. Now we have to calculate the total volume of the wall and we have to calculate the volume of each brick. Divide the first one from the second one. You will find the number of bricks required. So, therefore, volume of wall is equal to L into P into H. Here we have to be careful. This is in meters, this is in meters, this is in centimeters. So, convert all into one unit, either into centimeter or into meter. So, I will convert this as 0.24 meter. 0.24 meter. Or, so this is 10 meter into 100, 1000 centimeter. This is 400 centimeter. So, convert all into centimeter, let us say. So, we shall follow the textbook. So, I will write here, given wall L equals 10 meter equals 10 into meter is 100 centimeter. So, that is equal to 1000 centimeter. Now, breadth equals 24 centimeter. So we have converted this into centimeter. Let this be in centimeter only. And height equals 4 meter equals 4 into 100. That is 400 centimeter. So all in centimeters. Now, so therefore, volume of wall equals, so L into B into H, length into breadth into height, that is equal to 1000 into 24 into 400 centimeter cube. You call this equation as 1. Now you calculate the volume of each brick. Volume, brick size they have given, volume of each brick equals, so brick is also a cuboid, LBH formula will work out there. This is brick size 24 into 12 into 8 centimeter. So therefore, this is 24 into 12 into 8. 12 into 8 centimeter cube. This is second. So therefore, this is the volume of each brick. So therefore, number of bricks required equals volume of wall divided by volume of each brick. That means equation 1 divided by equation 2. So this equals 1000 into 24 into 400 divided by 24 into 12 into 8. 12 into 8. So 4166.6 4166.6 or roundabout. This is, we cannot say 0.6 bricks, therefore you can enhance 4167 or it is equal to 4167 bricks. 4167 bricks. So total number of bricks required is 4167. Note down please. Now, solved example 12. Example 12. So, it's a figure is given, a child playing with bricks blocks, building blocks which are of the shape of cubes, has built a structure as shown in figure. If the edge of the cube is 3 centimeter, find the volume of the structure of the building. So it is given like this. So this is how it is given. This is 5 blocks, 4 blocks, 3 blocks, and 2 blocks. It is a simple problem. So these are cubical blocks used for kids play. So here each block is having, it is like this. You can imagine this. It is like this. So it works out like this. So like this. So they are arranged in the form of a step book. So here the question is, this cube is 3 centimeter. So given edge of cube is equal to 3 centimeter. It is a cubical in nature. It is a cube. Therefore, volume of each cube is equal to, see, we have this formula, volume of cube is a cube. So where is A is the side length. This is 3 cube. So that is 3 into 3. So 27 centimeter cube. And the question is, total volume is how much? You can count these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 cubes. So therefore, the volume of 15 cubes, 15 cubes equals 15 into 27. 15 into 27, that equals 405 centimeter cube. So that's all. It's a simple problem. Now I will move on to exercise 13.5. Exercise 13.5, question number 1. A matchbox measures 4 centimeter, 2.5 centimeter and 1.5 centimeter. What will be the volume of a packet containing 12 such boxes? So, matchbox with the length is equal to 4 centimeter, breadth is equal to 2.5 centimeter, and height is equal to 1.5 centimeter. Therefore, volume of each matchbox equals LBH, that means L into B into H. So 4 into 2.5 into 1.5. So this equals, so 2.5 into 4 is 10, 10 into 5 is 1.5 is 15. So this is 15 centimeter cube. 15 centimeter cube. Now, the question is such boxes containing 12 each. So, how many? 12 matchbox in a box. 12 in a box. So, therefore, the question is a matchbox measures this much. What will the volume of packet containing 12 boxes? So, packet containing 12 box, volume of, you can write volume of packet containing 12 box equals 12 into 15, that is 180 centimeter cube. That's all. Note down please. Now I will move on to, this is the answer. So now we move on to second question. Question number 2. A cuboidal water tank is 6 meter long, 5 meter wide and 4.5 meter deep. So it is a water tank. It is 6 meter long and 2.5 meter wide and 4.5 meter deep. So this is 6 meters. This is 4.5 meters. This is a water tank. So from here to here 6 meters and height is 4.5 meters. So this is length, this is height, and breadth is, it is like this. This is a water tank. So this is, breadth is 5 meter wide, 5 meter. This is the water tank. Now, how many liters of water it can hold? So they have given water tank So length 6 meter, breadth 4.5 meter, depth, height you can say, height 4 point, breadth is 5 meter, sorry, height is 4.5 meter. So one more hint they have given, 1 meter cube will hold 1000 liters. 1 meter cube equals 1000 liters. So if that is the case, so how many liters it will hold? So we have to calculate the volume. So therefore the capacity of, we call it as a capacity of the tank. So therefore capacity to hold, capacity of tank equals, it is length into breadth into height, it is 6 into 5 into 4.5, 6 into 5 into 4.5. So 135 meter cube, 135 meter cube. See, 1 meter cube can hold 1000 liters. So therefore 135 meter cube. So therefore meter cube, that is equal to 135 into 1 meter cube is 1000 liters. So that is 135 followed by 30 liters. That is 1,35,000 liters. 1,35,000 liters. That is the capacity of the tank. Now I move on to next problem. Question number 3. A cuboidal vessel is 10 meter long and 8 meter wide. So cuboidal vessel, L is equal to 10 meter, breadth is equal to 8 meter. How much high must it be to made hold 380 cubic meters? So given volume is equal to 380 meter cube, and what will be the height of that vessel? This is a simple question. We have volume is equal to L into B into H. This is 380 equals L is 10 into B is 8 into H is not known. Just calculate H, that's all. Therefore H equals 380 by 10 into 80. 10 into 8. So that is, you will get this 0 cancels. So you will get 8 ones are and 8 fours are. 756 4 divide it 7 5, so 5s are, so you will get height will be equal to 3.75 meter. That's all. So a tank of size length L 10 meters, breadth 8 meters and height 3.7 meters will hold 380 meter cubes of water or into 1000 liters. Into 1000, so that means 3,80,000 liters. So dear students, I will stop at this stage. So I will take up the remaining problems in the next session. Thank you all.